There is a fleet on the ocean right now that has no real comparison anywhere else on Earth. It is not a fantasy. It is not a concept render. It is already built, already working, and China made every single piece of it. We are talking about a ship that can crack through ice moving forward and backward, a platform that drills deeper than Mount Everest is tall, and a vessel that can lift 12,000 tons with the precision of a surgeon's hand. Some of these machines do not even have a real comparison on land. They are rewriting the rules of trade, energy, and ocean engineering all at once. Today, we are breaking down the ships that prove it, 5 categories of pure engineering ambition. And the last one on this list does not move cargo. It does not move minerals. It moves power itself, and that changes everything. It starts with a ship that told the world China was done depending on anyone else. The Xue Long 2, which means Snow Dragon 2, was designed and built entirely with Chinese technology. That had never happened before. Most icebreakers only go forward. They push ahead, crack the ice, and keep moving. That is it. The Snow Dragon 2 can break ice going forward and backward, spinning through frozen channels that would stop a normal ship dead in its tracks. It crushes through 1.5 meters of solid ice like you would step on frost on a window. Inside, it carries 8 science labs and space for more than 90 people, and it can stay out for months without heading back for fuel. That gives China a steady presence in the polar regions that simply was not possible before. And that matters because the polar regions hold some of the most valuable resources on Earth. Being there on your own terms changes who gets access to them. But going from frozen surface water to the deep ocean takes a completely different kind of machine. CNOOC 981 is China's first homemade ultra-deepwater drilling platform, and it is basically a 20-story building floating in the open sea. Add the depth of the water to the depth of the seabed, and it can drill down more than 8 miles, deeper than Mount Everest is tall. It was built to handle waves over 100 feet, and it houses more than 200 workers while staying locked in place using a mooring system of massive chains, anchors, and thrusters running around the clock. Before this platform existed, China had to rely on foreign companies just to reach energy sitting off its own coast. Once the CNOOC 981 was built, that dependency ended. But conquering still water and calm drilling is one thing. What happens when you have to keep drilling while the ocean itself is trying to tear everything apart? Sometimes the challenge is not depth, it is sheer size. The Hongqi is a bulk carrier that stretches almost 1,200 feet long and can carry 400,000 deadweight tons in a single trip. That one voyage carries enough raw material to build 50,000 cars or supply the steel for 15 skyscrapers. The reason ships like this matter comes down to money and efficiency. Instead of sending 4 or 5 smaller ships burning 4 or 5 times the fuel, one giant makes the trip once and gets it done. When it is fully loaded, it sits 75 feet below the waterline, so deep that only a handful of specially built ports on the planet can even accept it. Every voyage saves millions of dollars in fuel and shipping costs, and that shift ripples through the entire chain of how goods get made and sold around the world. But moving raw materials in calm water is one challenge. Drilling for them in the middle of a storm is a completely different one. The Haiyang Shiyu 982 is a semi-submersible drilling platform built for some of the roughest ocean conditions imaginable. It can drill in 3,000 meters of water while storms tear through the surface above it, all thanks to a design where most of the hull sits below the waterline, out of reach of the worst wave energy. The platform rides on giant pontoons sunk deep underwater, connected to the working deck by massive steel columns. So even when 50-foot waves are crashing above, the drilling floor barely moves. China went from having 0 deep water drilling ability to running several of these platforms in under 20 years. That kind of speed does not happen by accident, and it means China can now work straight through typhoon season instead of packing up and leaving, saving enormous amounts of time and money. But what if the resources worth chasing are not oil at all, but something sitting in total darkness at the very bottom of the world? This is where things start to sound like science fiction. The Da Yang Hao is a deep-sea research ship that can send robotic vehicles down to 36,000 feet, the depth of the Mariana Trench, the deepest point on the entire planet. These robots do not need to come back up for tune-ups. They run on AI systems built to work under pressure that would flatten normal equipment in an instant. The ship acts like a mother vessel, lowering high-tech submersibles into total darkness to map the seafloor and pull up samples. Why does this matter so much? The ocean floor is covered in rare earth minerals, cobalt, nickel, and manganese nodules, the exact materials needed to build electric car batteries and smartphones. As the world moves toward clean energy, demand for these materials keeps climbing, and whoever reaches the ocean floor first gets a massive head start. China is not just studying how to do this, it is actively scaling it into a real working system, years ahead of countries still writing up plans in meeting rooms. But collecting resources from the bottom of the ocean is only half the story. Getting finished goods to your doorstep takes a completely different kind of giant. The Costco shipping universe is 400 meters long and carries more than 21,000 containers in a single trip, like a freight train 47 miles long moving across the ocean as one vessel. Every container gets loaded using computer programs that calculate the perfect weight balance, because if the math is off by even a little, the stress on a ship this size becomes a serious problem. Costco's network reaches 160 countries across more than 320 international shipping routes, which means the odds that something in your own home passed through a ship exactly like this are actually very high. And China runs dozens of these routes at once, every single day, moving the modern world forward one container at a time. But this was only a warm-up for what came next, far above the water. Here is where things start getting truly wild. The Fujian is China's most advanced aircraft carrier, and it launched in 2022. It displaces between 80,000 and 85,000 tons and stretches over 1,000 feet long, putting it right up there with America's biggest military ships. Think of it as a floating airbase that can project power thousands of miles from China's coast. But the size is not the real story here. What makes the Fujian so special is its electromagnetic aircraft launch system, the same cutting-edge catapult technology that even most of the world's top navies do not have. This system lets heavier planes take off carrying more weapons and fuel, making the carrier far more capable. The flight deck can handle 50 to 60 aircraft, and during operations, the electromagnetic system can launch a plane every 30 seconds, a speed older steam catapults simply cannot match. China went from having 0 carriers in 2012 to running 3 today, with more said to be under construction, and that pace shows just how fast this program has moved. But building air power is one kind of engineering. Building with millimeter precision in open water is another entirely. The Jinhua 30 is 679 feet long and can lift 12,000 tons with its crane system, about the weight of 80 fully loaded Boeing 747 jumbo jets, all lifted at once. But the real achievement is not the power, it is the precision. This ship was the main vessel used to build the Hong Kong to Zhuhai to Macau Bridge, the longest sea-crossing bridge ever built, placing 33 giant concrete and steel sections with pinpoint accuracy, while fighting ocean currents, shifting tides, and typhoon season. Using a dynamic positioning system with multiple thrusters, it held its exact spot for hours during critical lifts, refusing to drift even a few feet. The company behind it, ZPMC, now makes over 70% of the world's port cranes. Every ship on this list moves something: cargo, minerals, aircraft. What comes next does not move objects at all. Everything else on this list moves things: cargo, minerals, aircraft, steel. What comes last does not move goods, it moves power itself. China's floating nuclear power plant program is built on Linglong small modular reactor technology, and it might be the boldest maritime engineering project ever attempted. The idea sounds simple, but the execution is staggering. Build a nuclear reactor small enough, safe enough, and steady enough to run on a floating vessel, Then sail it anywhere on Earth that needs power and plug it in. One vessel produces 125 megawatts, enough electricity for 150,000 homes, and it can go almost anywhere on the ocean. Keeping a nuclear reactor stable at sea sounds nearly impossible, and without the right engineering, it would be. Chinese designers built backup cooling systems and stabilization technology strong enough to keep the reactors safe even in rough seas, something no other country has done at this scale on a moving platform. Think about who actually needs something like this. Remote Pacific islands burning diesel shipped in by boat just to keep the lights on. Offshore platforms running on expensive, dirty generators. Coastal regions in the developing world where building a normal power grid would take decades and cost billions. You sail this vessel in, connect it to the local grid, and the problem is solved. When the reactor needs maintenance, you sail it out and bring another one in. The Xue Long. One became the first small modular reactor in the world to pass the International Atomic Energy Agency's safety review, a process so demanding that most designs never make it through. Russia has a floating nuclear station called the Academic Lomonosov, but it stays locked in one spot. What China is building goes further, a vessel that can be moved and sent wherever it is needed most. It is not a small step forward. It is a completely new way of thinking about how the world gets power. Line up everything on this list, from a ship that breaks ice in both directions, to a crane that built the world's longest sea bridge, to a floating nuclear reactor that can power a city from anywhere on Earth, and they all point in one direction. China is not building ships to catch up. It is building for a world that has not arrived yet. If any of this blew your mind the way it blew ours, hit the like button and subscribe so you do not miss the next one. Now I want to know, if you could only sail on one of these ships, which one would it be?